Hello, I'm Richard Bishop, leader of Team Lux. Our team is sponsored by Ibeo Automobile Sensor and Zick AG. We're pleased to be part of the 2007 Urban Challenge. This is Leaks, our Urban Challenge vehicle. It is a 2006 production Volkswagen Passat. You can see that it looks very much like a production vehicle. Our mission in the Urban Challenge is to prove that environment perception for autonomy can be accomplished via laser scanner technology alone. 3 laser scanners are integrated into the body of Leaks at the bumper level. There's one in each front corner. The coverage area is 220 degrees with a range of 200 meters. The rear laser scanner is integrated here. This combination of sensors gives us excellent forward, aft, and side coverage. Leaks is fully actuated for autonomous control. We have chosen not to interface with production components, and instead the actuators are retrofitted. The brakes are operated by a linear actuator connected to the brake pedal. We can apply maximum braking force much faster than a human driver. For steering actuation, there is a motor connected to the steering column. Holger will now demonstrate a 90-degree turn based on a command from the controller. The production accelerator pedal for Leaks is electronically controlled, and we interface to that circuit for throttle control. Gear shifting is available on the vehicle CAN bus and is electronically accessed by our controller. The blinker and parking brake can be commanded through the CAN bus as well.
This is the power supply for all the components, processing actuators. That is the e-stop unit, and on the next level we have the processing system. It's 2 ECUs, 1 backup system and the vehicle controller. And below that we have the GPS receiver, the steering, motor controller, and the battery backup for all the systems.
The e-stop system is fully compliant with Urban Challenge rules.
The Lynx is doing the e-stop now and starts again.
You can see that we have laid out a 2-way 320-meter track, complete with 90-degree turns and 4.5-meter lanes. This track is fully compliant with DARPA video guidelines. How can a laser scanner detect lane markings? During the forward scan, typical reflections from the lane markings are detected. If there are no lane markings, we detect curbs or other features. In addition, the mirror which directs the laser rotates 360 degrees, which means it is looking backwards into the car for a portion of every scan. In this scan segment, we use a special mirror feature to direct the laser down onto the pavement to get a higher quality reflection of the lane markings. Team Lux uses a novel approach to navigation. For positioning, we use a high-precision OmniStar GPS receiver. We don't need an inertial measurement unit. Instead, the laser scanner is used to track features such as trees, corners, and poles. This allows us to calculate ego movement in the X and Y dimensions relative to the ground, giving us the equivalent function of an IMU in terms of yaw rate, shift, and rotation. But actually our approach is better than an IMU because there's no drift. Leaks exhibits the required 5-second pause after entering run mode. Team Lux is the only Urban Challenge team using a prototype of Ibeo's next-generation laser scanner. Leaks is now traversing the track at approximately 10 miles per hour, slowing for turns. It is performing autonomous navigation, waypoint following, lane keeping, and obstacle avoidance. If it rains today, for instance, this presents no problem for Ibeo laser scanners due to the 4-echo technology. The sensor can see through rain, fog, and other precipitation. You can see that Leaks detects a stopped vehicle in the travel lane. Leaks points outwards a bit to look for any oncoming traffic, stops, signals, and then changes lanes to pass the obstacle. Safely returning to the travel lane. This line marks the start and stop location for the track.
We are ready to go!